Hey everyone, it's Mr. Anderson back with you again. We're in our CPM textbook in section 5.1.1. It is the second lesson for this section. So if you did not watch the first one already, you're going to want to go ahead and make sure you've done that. Back up, make sure you've done that. Otherwise, the context may not make a ton of sense today. But one more time, we're going to investigate this growth rate of a function that is not linear, right? So we're going to reinspect what happened yesterday. We're going to modify a couple things, though, and we are going to see how that impacts things, right? See what kind of an impact that has. We're going to be given some situations, and we're going to be transitioning from the situation to the table today. And then by the time we're done, we're going to train both of those things and talk about a graph, right? We're going to get to the equation eventually. Not quite there yet. Okay, but here we go. Lenny and George, same two guys, raising rabbits, going to live off the land and their production from rabbits, right? And they want to have as many rabbits as possible, right? That's their goal. They want to be as productive as possible, make some make some cash and be successful, right? They could start with a large number of rabbits, or they could raise a breed of rabbits that reproduces faster. How do you think that each of these options changes their pattern? All right, which situation might yield the largest population after 1 year, right? Because if we're really concerned with that, we want to have a large, healthy rabbit population for the purposes of sales or production or what have you. And we're going to start by focusing in on case 2. And I'm going to do a couple things here in part A that are going to set us up for success in the next part of this problem. So you might have some questions about why I'm doing what I'm doing. Trust me, I'll get you there by the time we get to problem 5-4. This is 5-3, by the way. All right, case 2, right? The first thing we're going to look at, okay? They want us to consider where we start with 10 rabbits. Yesterday we started with 2. Today, in case 2, we're going to start with 10, and each pair has 2 babies per month, right? This, as we identified yesterday, means I'm doubling, right? I'm multiplying by 2, and we spent time talking about that yesterday, okay? So let's go ahead and let's fill in our work for case 2 here, right? Case number 2 is right here on the left-hand side of my table. Start with 10, and we are doubling. All right. Month 0 to month 1, right? The starting point to 1 month later. Each pair has another pair. We're doubling. Okay, and then we continue to double, right? If you double 20, you get 40. Now I'm going to try to zoom in here a little bit and make my writing slightly more legible. All right, if we double 40, we get 80. If we double 80, we get 160. If we double 160, I'm looking over here because I got my notes over here on my other computer. If we double 160, we get 320. If we double 320, we get, sorry about that, we get 640. If we double 640, we get 1,280. If we double that, we get 2,560. I'm going to keep going. 5,120 is what I get if I double 2,560. Then I'm going to get really big, 10,240. All right, here's where maybe you need to get a calculator out if you don't have one already. Double 10,240. I'm going to get 20,480. One more doubling to get to the end of my first year, 40,960. So far more rabbits than the number of rabbits we saw yesterday. Okay, looking pretty good. Lenny and George, it looks like they've got themselves a pretty rock solid system. But is that the only option they have? Well, case 3 changes some things. Case 3 says start with 2 rabbits and each pair has 4 babies per month. Okay, now let's look at this. This starting point is the same starting point we had yesterday in our previous lesson. Start with 2. That part probably not too tough. But what does it mean to have 4 babies each month? That means we're going to go from 2, and then each pair has 4. So we're going to go, let's see, 2 to 6, right? Oh, I'm sorry. Each pair has 4 babies, not each pair has 4 pairs. That is what I meant to say. That's why we're going from 2 to 6. Okay? And then each pair is going to have 4. Those are going to have 4, so it's going to go from 6 to 18. And then, what in the heck, right? Each pair, let's see, 18 to 50, 54, right? Okay, so here we go. 2, and then we're going to go 6, and then we're going to go 18, and then 54. And if in case this is not abundantly clear, right? Let me. I'll try to draw a little picture, but I'm going to use ours instead of drawing the bunnies today because I'm not a great artist. You start with 2 rabbits, right? We got to have 2 rabbits to be able to make babies, and then they have. But then they have 4 rabbits, so that's another 1, 2, 3, 4. And that's why we have a total of 6, right? Not 4 pairs of rabbits, just 4 rabbits total, right? So this is like the actual pair of rabbits. They just continued to live for 1 month, but then they would have these 2 and these 2. So we would have a total of 6. So it's almost like, this is tripling. Okay. Okay, let's just keep going then, right? 54, I take that and triple it. I get 162, and then I get 486, and 1458. Now, I'm already realizing as I make a quick comparison from let me zoom out, case 2 to case 3, I'm already realizing that case 3 appears to be a superior case to case 2. So if I'm only concerned with the number of rabbits, I'm really interested in case 3. Now, I'm going to just go ahead and keep doing this tripling for you guys. We are going to get pretty big pretty quick here. 13, 122, 39, 366. 118, comma, let's see, 098, and then 3, 294, and then 1,062,882. So here we go. George and Lenny are in a position where they have over 1 million rabbits at the end of the year, and what are they going to have to do? Well, they might have to take into account some special considerations like, hey, are we able to care for this many rabbits? All right, let's go ahead. Let's tackle case 4. Case 4 says start with 2 rabbits. Okay, that's no problem for me. And each pair has 6 babies per month. Okay, so if I start with 2, rabbit, okay, they're going to continue to live there, right? And they have 6 babies, so that's going to be like 3 pairs. Rabbit, 1, 2, 3, 4. 5, 6, rabbit. Okay, so that's like quadrupling. Okay, so we're going to start with 2 rabbits and we're going to quadruple, and you guys can probably imagine what's going to happen here. We go from 2 to 8, we go from 8 to 32, we go from 32. I've got this written down over here. This is how I'm able to do this so quickly. 5, 12, 20, 48, and look at what's happening already. If I compare this to that, already it looks like case 4 is going to be significantly superior. And trust me when I tell you it is, because by the time we make it to the bottom here, we're going to have 33,554,432 rabbits. So case 4, oops, let me slide that up so you can see. Case 4 is going to be the far superior method, right? And that's what the continuation starts to ask here, right? It says, hey, which case would appear to give Lenny and George the most rabbits after 1 year? And I think it is going to be case number 4. And how many is that, right? This is what we discussed yesterday. The table method gives me a superior method for like doing the math, showing my work, and then also, as we're about to see in a second, the opportunity to do the graphing here. So that's pretty important here. But Lenny and George may want to make some considerations here. Do they have the ability to care for 33 million rabbits? Is that a thing for them? I don't know, right? Okay, let's go ahead and keep on keeping on, because question number 4 ties into this, right? It says, what do they all have in common? And I made a little note ahead of time here. It looks like instead of adding the same thing every single time, they're all being multiplied, right? It doesn't appear if a constant's being added, they're all being multiplied by a constant. And that's the thing that creates this new growth pattern for us. And we're going to see, you guys can click this in your book, a new Desmos E tool that asks us to do some graphing with our work from case 2. So I'm going to take this and I'm going to plug this in. So for the first time we can, this is that E tool by the way. So for the first time we can see what this looks like. And the folks over at CPM and Desmos, they built this for us. And it's as simple as taking the months and the rabbits and entering my data. And I can do this and this will start to graph that graph for me. I'm just typing in exactly what we worked out. All right, 4 and 160, and then 5 and 320, and then 6 and 640, and then what comes next? 7 and 1280, and then 8 and 2560, and 9 and 5120. All right, let's see, 10,240. And then 11 and 20,480, and then 12 and 40,960. Okay, so hit enter there, and I'm going to zoom out here, and you guys are going to see, you know, my graph gets really, really big. I can even zoom out more. My graph gets really, really big, really, really quick. Look at that. Oh my gosh. Okay, but if I zoom back in, we can see very, very clearly that this is not a straight line, right? I could not take and connect all these points with a straight line, like from there to there. So what did this create? It created a faster growth rate for us, and this faster growth rate means that we're not growing at a constant rate. We're growing at a multiplying rate, and it creates a little bit of speed. It creates a curve. And here, for the first time, now we're seeing that curvature graphed, and we're seeing a function in nonlinear algebra that isn't linear. And that's a pretty cool thing. We refer to this thing as, of course, an exponential curve, okay? This is what's called an exponential growth pattern, because as the number, and I'm going to cheat this up a little bit so you can see the months here. But as the number of months go on, my number of rabbits is growing over time, and it ends up growing very, very, very quickly. Okay, because of the way and the nature that rabbits reproduce. Okay, we talked about the shape of the curvature of the graph, right? We would call this a curve versus a line. We talked about why that happens, right? Because we're not growing by the same number every time. For example, from here to here I grow by 10. From here to here I grow by 20. From here to here I grow by 40. That is not the same number of rabbits being added to my rabbit population. I'm doubling, and that's what creates this curve. Okay, ladies and gentlemen, a little bit of review preview today, all right? And that review preview you're going to find right here. It's 512 to 516. As I brought up yesterday, the opportunity to try some of these things and generate some questions so you know what to ask if you're in the need of help is a very powerful thing. And the only way you get that is by trying some of these things in the practice, so to speak. Folks, thanks for watching. Have a great day.